Okay guys, so this is going to be vectors and right triangle trig example problems. So in this lesson we're going to be dealing with a lot of the stuff we did from the right triangle trig lesson, but we're going to be dealing with vectors. So the definition of a vector is anything that has magnitude and direction. When we're talking about physics or math, we're going to be using vectors, okay? A vector is drawn from the origin up to or down to a point. We're going to use our knowledge of right triangles, and we're going to find the remaining trig ratios. Okay, so first example problem. It says cosine of theta is equal to a negative 3/4, and it's drawn to quadrant 2. Okay, so what we're going to do is we're going to draw a right triangle to quadrant 2. Now it's important that your angle is always made with the x-axis. Okay, your reference angle. So it's always going to look like that when we draw the quadrant 2. Okay, so cosine is adjacent over hypotenuse. So your adjacent's a negative 3 and your hypotenuse is 4. Your hypotenuse is always positive. Okay, so that means that the other side would have to be negative, or they both are negative. Remember, in quadrant 2, your x-coordinate is negative and your y-coordinate is going to be positive. Okay. So we're missing a side, so we're going to have to do our Pythagorean theorem. So negative 3 squared plus b squared is equal to 4 squared. Negative 3 squared is 9. 16. Okay, so b squared comes out to be 7. So b comes out to be square root of 7. Okay, so it's going to be a positive square root of 7 because I'm in quadrant 2. And my y-coordinate is going to be positive. Okay, so we're going to find all the trig ratios dealing with this. Okay, so sine of theta. And I'm always going to write them in this particular order. That way my life's easy. Just the way we learned it whenever we did our trig chart also. Secant of theta and cotangent of theta. Okay, so if we're going to label our right triangle, this is going to be our opposite, this is our adjacent, and this is our hypotenuse. Okay, so sine of theta is going to be square root of 7 over 4. Cosine is already given to us as a negative 3/4. Tangent is opposite over adjacent, so it's a negative square root of 7, sorry, I hit my camera, over 3. Now, I haven't ran across this, but usually some people mess up on this. Usually when we write negative signs, we don't write it on the bottom. It's not wrong, it's just bad math. So we either write it on the top or we write it out to the side. Okay, so if you're asking if I wrote a negative 3 on the bottom, no, it's not wrong, but we don't usually write it like that. Now we're going to go through and flip them. And this makes sense because in quadrant 2, anything dealing with sine is positive. So those are the only two trig ratios that should be positive. Everything else should be negative. Okay, on to the next example. It says a vector is drawn to the point 1, 3. Okay, we know from basic math that the point 1, 3, something like right there, right? Doesn't have to be perfect. Okay. My right triangle looks like that. I probably should have drawn it bigger. Now, we're given the x-coordinate and the y-coordinate. So your x-coordinate is going to be 1, your y-coordinate is going to be 3. Now, to find the third side, we're going to use our Pythagorean theorem. So we're going to do 1 squared plus 3 squared is equal to c squared. Okay, so 1 plus 9 is equal to c squared. So 10 is equal to c squared, so square root of 10 is equal to c. Like that. Everything's positive in quadrant 1. And I just want to go back up to the first example real quick. If you need to put this in the calculator, Lord, heaven forbid that you put this in the calculator, you have to make sure you use parentheses. Anytime you square a negative number, you have to use parentheses, or else it's going to be, it'll come out negative, which isn't true. Anything squared is always positive. Okay, so let's label our right triangle. This is going to be our opposite, this is our adjacent, and this is our hypotenuse. So we're going to write our trig ratios in the same order we've been doing the whole entire time. Okay, so sine. Sine's the opposite of our hypotenuse, so it's going to be 3 over square root of 10. Cosine is going to be 1 over square root of 10, adjacent over hypotenuse. And your tangent's opposite over adjacent, which is 3 over 1. Okay, now we're going to go through and flip it. Now you don't have to leave it as over 1. You could just write square root of 10, or you can just write 3. That's okay with me. I just do it so you can see the fraction and the ratio. Okay, next example problem. It says if cotangent of theta is equal to a negative 3/7 and it terminates in quadrant 3, we want to find the remaining trig ratios. Okay, so that's not right. I'm going to change this to quadrant, change this to quadrant 4. Because cotangent should, actually. Let's leave it quadrant 3. Let's make it positive. I'm going to go through and change this on your worksheet whenever I'm done with the video. Let's make it positive. Okay, so cotangent is positive in quadrant 3. That's what happens when you make up your own problems. Our angle is always with the x-axis, like that. And cotangent is going to, that doesn't make sense at all. Let's do 7/3. Let's make it 7/3. I'm going to change this on the worksheet so it'll look right whenever you see it. Okay, so cotangent of theta is equal to 7/3. So cotangent's hypotenuse, no. That's what I was. Let's leave it positive and leave it 3/7. My bad. I was thinking I was having to deal with the hypotenuse. Okay, so cotangent is adjacent over opposite. Okay, so your adjacent side is going to be 3 and your opposite side is going to be 7. Now, in quadrant 3, we're dealing with a negative x and a negative y. So this has to be a negative and this has to be negative. The reason it comes out to be positive is because we're doing a negative divided by a negative. Okay, now when we go to do our trig ratios, we have to have the third side. So we're going to use Pythagorean theorem. Okay, so negative 3 squared is 9. Negative 7 squared is 49. Okay, so 58 is equal to c squared. So c comes out to be square root of 58. Okay, and hopefully that makes sense to you all why we can't have it as a negative. That's either a typo or I just overlooked something. Okay, that's the whole purpose of going through and doing these ahead of time, so I don't have any mistakes. Okay, so this is going to be your opposite, this is your adjacent, and this is your hypotenuse. So sine of theta, cosine of theta, tangent of theta, and we're going to do cosecant of theta, secant of theta, and cotangent of theta. Okay, so sine is going to be opposite over hypotenuse. So this is negative 7 over square root of 58. Cosine is going to be a negative 3 over square root of 58. And tangent is going to be 7/3. Opposite over adjacent. And we're going to go through and reciprocate everything. the square root of 58 over 7. Okay? And then our last example problem. Sine of theta is equal to 3 over 5, and it terminates in quadrant 2. So we're going to draw a right triangle, and the angle has to be made with the x-axis. Sine is going to be opposite over hypotenuse, so 3 over 5. Now, if you don't know that this is going to be a 3, 4, 5 triangle, we can do Pythagorean theorem. So 3 squared plus b squared is equal to 5 squared. 9 plus b squared is equal to 25. B squared comes out to be 16. So b is equal to plus or minus 4. Okay? It's negative. So it's negative because we're in quadrant 2. Remember, quadrant 2 is negative x, positive y. Okay, so we're going to label our triangle. This is your opposite, your adjacent, and your hypotenuse. And we're going to go write our trig ratios down. Okay, so sine is going to be 3/5. Cosine is going to be negative 4/5. And tangent's going to be negative 3/4. And then we're going to go through and flip. And we finish up. So that's been your example problems for vectors and right triangle trig. Make sure that you know what quadrant you're dealing with and if it's positive x, positive y, that sort of thing. I will fix this example problem, so no worries on that. Sorry, it happens sometimes. Hopefully you have a good night. If you have any questions, let me know. Thanks.